you just skip over that. If you're doing problems in the book or anywhere and it says to use the calculator shortcut, just ignore it and go ahead and use the method we've used here. Now, the other thing we have to do, we've practiced going from another base into base 10. Sometimes we have to go from base 10 into a different base. And for example, you may want to convert 77 into base 5. In base 5, we know that 5 to the 0 is 1, 5 to the 1 is 5, 5 squared is 25, 5 cubed is 125. Now the number we're converting is 77, so we don't need the 5 cubed. That's too big. Once we get bigger than our number, we don't need it. So what we do is we actually just start dividing by our largest power of 5. That'll go in, and I'm going to think about my number over here. I know it's going to be, I'm going to need a digit for 5 squared, 5 to the 1, and 5 to the 0. Let me put these down here since I'm running into the words. So how many times does 25, which is 5 squared, go into 77? Goes 3 times. So we have 3 25s, and now we have 3 left over. How many 5s are in 3? None. How many 1s are in 3? 3. So our answer is, that should be a 2. I can't subtract. That should be a 2. Okay, so we have 2 1s left. How many 1s are in 2? We have 2 1s. So we can do it by using powers of the base that we're converting to. There is a shortcut on this that I do use sometimes, and as far as I'm concerned, you may choose either method, whichever one makes more sense to you. Basically what you do with the other method is you divide repeatedly your numbers by 5, and you keep track of the remainders. So for example, 5 goes into 77 15 times with 2 left over. 5 goes into 15 3 times with nothing left over. 5 goes into 3 0 times with 3 left over. Now we read the remainders in reverse, and you can see that I have gotten the same answer that I got by the other method by doing this repeated division. So let's do the shortcut on 129. We want to divide it into base 8. So I'm going to try the shortcut. And I do use my calculator for these division problems. Let me clear my screen. What I do is I take 129 and divide it by 8. The whole number part of that is 16. Then I multiply 16 times 8 is 128. So I can see my remainder would be 1. Alright, 8 into 16 goes twice with nothing left over. 8 into 2 won't go, so I have 2 left over. So I read my number in reverse. It's 201 base 8. Alright, now if we are asked to convert from a different base other than base 10 into another base other than base 10, we have to do the two-step process. What we initially do is we convert to base 10. So I'd have 1 times 5 cubed plus 4 times 5 squared plus 0 5, so I'm not going to write that down, plus 3 1s. So that's 125 plus 4 times 25 would be 100 plus 3. That's going to give me 225 plus 3. And so that would give me 228. Now I want to change 228 into base 9. So I'm going to divide that by 9, and again I'm going to use my calculator to keep me straight. Okay, 9 goes 25 times, and 25 times 9 is 225, so my remainder is 3. 9 goes into 25 2 times. 2 times 9 is 18, so my remainder is 7. 9 goes into 2 zeros, so my remainder is 2. And reading that backwards, I get 273 base 9. So you have to convert to base 10, going to base 10 first, and then go to base 9. Now, when you're converting from octal, or base 8, to base 2, we actually can take a shortcut. In the textbook, and I know the page number has changed, so let's see. And I'm only going to do octal to binary. It's the last two columns on page 185. So let me update the page number. That should be 185. And what you want to do is look at, in base 8, we only need the digits 0 through 7. So really you can stop when you get down to 7 in the octal or base 8 column. And you have the binary equivalents. 0 is 0, 1 is 1, 2 is 1, 0 in binary, 3 is 1, 1 in binary, 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, and 7 is 1, 1, 1. Those are the only ones you actually need. And basically what you do, here we have a base 8 number. The equivalent of 1 is 1, but we have to represent each number with 3 digits as we go to base 2. So that would be 001. And this is 2. I want to go ahead and put that down. Okay, my next number over is a 5. So I look to see what is the 3-digit representation of 5. It's 101. Alright, now I move left to the 3. Alright, it's a 1, 1, so I need to write it as 3 digits, so it would have to be 0, 1, 1. Finally, we need a 6. 6 is 1, 1, 0. So 6, 3, 5, 1 in base 8 becomes 1, 1, 0, 0, 1, 1, 101, 0, 0, 1, 2 in base 2. So it makes it a little bit quicker to do. Again, we can do this one just by looking at the base 2. 0, 0, 11 is 3. 1, 1, 1 is 7. And 0, 1, 0 is 2. So that would be in base 8. So we can take a little bit of a shortcut there. And the reason is because 8 is a power of 2. So that's the reason we can do that. And 8 we would represent with 4 digits, 1, 0, 0, 0. So, okay. So the next thing you need to do is watch the sample problems, and then you'll be ready to do the online homework.